Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over problems 1 to 5 of the August 2016 Algebra 2 Common Core Regents exam. If you have any questions at any point in time during this presentation, just feel free to ask your question in the comment section below, and we'll be more than glad to support you. All right, let's take a look at question number 1. It says, which equation has 1 minus I as a solution? So one thing you want to remember concerning quadratic equations with imaginary roots is that they normally come in pairs, okay? So recall quadratics with imaginary roots have conjugate pairs, okay? Conjugate pairs as roots. All right, so in order to get a conjugate pair, all you need to do is you negate the sign of the imaginary part. So let's consider an example. For example, if x equals 2 plus I is one root of a quadratic equation, guess what? X equals 2 minus I must be the other root. Okay, so these are called what? They are called conjugate pairs. Conjugate pairs. So we've been provided with one of the roots, 1 minus I. So now we're to find the quadratic equation that results in this root, okay? All right, so let's write down the following remark. If x equals 1 minus I is a root, then what does that follow? Then x equals 1 plus I, the conjugate, is also a root. All right, they always come in conjugate pairs. So let's go ahead and work backwards. We have the roots x equals 1 minus I and x equals 1 plus I as the roots. So we want to reverse engineer the polynomial that when you solve it, either by completing the square with the quadratic formula, you get these as the answers. Okay. So we're going to use the reverse of the we're going to solve this, set this equal to 0. So what we're going to do is subtract 1 minus I from both sides, right here, 1 minus I, and then we get x minus 1 minus I equals 0, okay? And then in this case right here, we're going to also subtract, 1 plus I, okay? So we want to set both of them equal to 0. So subtract 1 plus I, and then subtract 1 plus I. We're working backwards. Okay, so we're going to have x minus 1 plus I equals 0. All right, remember when you're solving a quadratic, you're trying to get x isolated, right? So with working backwards, since x is already isolated here, we're working backwards. So now we have the 2. We're now going to use the reverse of the zero product property to express this in the factored state of the quadratic equation that resulted in these two roots, okay? So what we'll simply do, the reverse of the zero product property, will have x minus 1 minus I times x minus 1 plus I equals 0. Okay? All right, so all we're simply going to do now is we're going to expand this completely, and then that should give us the quadratic equation that has these as the roots. So let's distribute the minus first. So we'll distribute the minus. We have x minus 1 plus I times, distribute the minus here, x minus 1 minus I. All right. Now, there are different ways you can do this. There's a neat little advanced strategy for expanding this, but it's a little bit too abstract. It's better for pre-calc, but I'll just show you another method that works. This method is not that abstract, and it's very likely for you to get, you're very likely to get it correct, okay? The odds of making errors using this method is pretty slim. That's why I would like to show it to you. Okay, this is known as the box method. Okay, so we're going to create a box and then we're going to multiply like a typical multiplication chart. So let's take the first factor. We have x, and then we have -1, and then we have I. All right, so for each term, we're going to create a row. Okay, so that's the x row. This is the -1 row, and then this is the I row. Okay, a lot of times students like to use boxes, but this riddle works perfectly well. Now this one, I'm gonna now create columns using the terms of the second factor. So we have x -1 minus I. All right, so let's go ahead and create our grid. So we have the x column, the -1 column, and then the I column. All right. Students, like I said earlier, just like creating boxes with this approach, but whichever way you want to draw it doesn't really matter. Just have it nicely organized by row and columns. And then all you just do is multiply like your typical multiplication chart. So let's go ahead and do it. X times x is what? X squared. Remember, you have 1 and 1 as a power. And when you multiply exponents with the same base, you add the powers. Okay? And then x and -1, if you times it, you get negative x. Negative I times x is negative ix. Okay, second row. X times -1 is negative x. -1 times -1 is +1. Negative I times -1, remember minus times minus is plus, okay? So positive I. Okay, now third row. X times I is positive ix. -1 times I is negative I. And then negative I times I is negative I squared. Now the nice thing about this chart is it organizes everything in such a way that we can easily combine like terms, okay? So let's start with the second degree term. X squared stands alone. There's nothing to combine it with. Now, if you look at the negative x's, we can combine these two, right? Negative x minus x. Can combine those two. Minus x is minus 2x. And then you have negative ix and positive ix. What happens when you combine negative ix and positive ix? They are opposites, so they add up to 0. And then we have +1. There's no constant to add that to, so we just leave it +1. And then we have, what do we have? Positive I minus I. When you combine these two, what do you get? You get the opposite. Oh, so that becomes 0, and then we have negative I squared equals 0. Okay, this looks much better. Now, do you remember what I squared equals? You want to remember how I came about. I squared is equal to -1 because the square root of I is -1. Is the square root of -1. I is the square root of -1, so I squared is equal to -1. Okay, so we're going to make a substitution there. We're going to take away I squared and replace it with -1. So we have x squared minus 2x plus 1 minus, instead of I squared, we're going to put -1, okay? Because that's what I squared is. Remember, anytime you have I with powers greater than 1, you have to reduce or simplify. So now we have x squared minus 2x plus 1 minus times minus, slash and dash becomes plus 1 equals 0. And then we have x squared minus 2x plus 2 equals 0 as the quadratic with the roots that were given, one of which is 1 minus I. Okay, so that was our final answer. Our answer is option number 4. Okay, option 4 is the answer to question number 1. All right, let's take a look at question number 2. It reads, which statements about statistical studies is true? So this question basically assesses your understanding of what a good statistical sample is. Okay, So take a look at this tip real quick before we take a look at the question, the options. Consider a good statistical sample. Now, when you want to sample a population, a lot of populations are made up of groups or levels. For example, we have different ages or different classes or different races. So those are the groups within the population. So a good sample should be made up of a snapshot of each group or sample, each group or level within that population. Okay, so this problem has to do with schooling, most of them. So let's take a look at the first one to illustrate this point, okay? So it says the survey of all English classes in a high school would be a good sample to determine the number of hours students throughout the school spend studying. Okay, so you want to have an idea, you want to have a snapshot of the number of hours that students in the entire school spend studying. Now, if you focus on just the English classes, is that a good sample? Well, if you think about English classes, at what grade levels do you have English? Well, in most schools, you have English at the 9th, you have English at the 10th, you have English at 11th, and you have English at the 12th grade levels. Okay, so if you're picking, if you take a look at all the English classes, you're very likely to hit a portion, like I have a snapshot of all the grade levels in the entire school. So that's the goal. You don't want to miss any grade level. You want to try and get a sample from each of them. So this type of sampling is excellent because English, just selecting the English classes alone, you're very likely to hit all the grade levels within the school. Okay, so this is good because it hits all the grade levels. It's very likely to do that. All right, so our answer is option number 1. Okay, or this is a good sample. Well, this is a multiple response question, so this one is good. Now let's go ahead and consider the other ones because we want to see which of them are true, okay? So this is good. Option 2, we have, it says a survey of all 9th graders in high school would be a good sample to determine the number of student parking spaces at the school. So for this one, if you think about parking spaces, what are you looking at? You're looking at students that have cars. So this is a, let's say this is a Venn diagram. Students that have cars, well, what is the grade level of most students with cars? If you think about how old you have to be to have a license. Mostly 12th graders or sometimes 11th graders, so 11th and 12th. And we are sampling the 9th graders. Most 9th graders do not have cars, so is that a good sample to determine the number of parking spaces needed at a school? The answer is no. Okay, because look at it, the intersection is very likely. It's very rare to see a 9th grader that has a car. Okay, so this is no good because most 9th graders do not have cars, so they don't even think about parking. So let's write it down. Most 9th graders do not have cars. Okay, all right. Now let's take a look at the next one. A survey of all students in one lunch period in a high school would be a good sample to determine the number of hours adults spend on a social media website. Okay, so let's see. We have, this is the adults. This is what we want to have a snapshot of. Adults that, I mean, the hours adults spend on social media, adults' time on social media. Now, which fraction of this population are students in one lunch period? Students are not adults, right? Most of them are not adults. So we have students somewhere here. So if you take a look at just students, in one lunch period, how many of them hits the different groups, let's say age groups or races of adults? None of them. Okay, so students are not in this adult space, so they don't know how much time adults spend on social media. Okay, so this is a bad sample. So let's say students are not on adult social media sites. Okay. If you want to know about what students use, then you check with students. If you want to know what adults use on social media, then you check with adults. So this is a bad sample. Okay. Now let's take a look at the fourth one. It says a survey of all calculus students in high school would be a good sample to determine the number of students throughout the school who do not like math. All right. So let's say we have a sample here of the calculus students. What do we know about calculus students? In high school, most calculus students in high school love math, right? That's why they're taking calculus, because calculus is not required at a high school level. This is a college level math class. So if you're in calculus in high school, then there's a strong possibility that you are good at and like math, okay? How about students who do not like math? What are the odds that you're going to see them in calculus? Very unlikely. So here we have, this is just a snapshot of the students who don't like math. So hate math. What's the overlap? How many of the students that hate math are in calculus at a high school level? There isn't any overlap. So can this give you a snapshot of what's going on here? All right, the answer is no. Okay, actually, I gotta switch it around. So what we want to do, this is a bigger subset. So we're looking for students who hate math, and then students in calculus. So this is a smaller group right here. So the question is, can we look at the students who are in calculus to determine, to sample students who hate math? And the answer is no, because there's very little overlap between students who are in calculus who love math and students who hate math. So what does that mean? That means that this option 4 is a bad sample. So the answer for question number 2 is option number 1. Only option 1, that's the only one that is a good statistical sample. All right, let's take a look at question number 3. It says to the nearest tenth, the value x that satisfies 2 to the x equals negative 2x plus 11 is. So this problem involves the use of our graphing calculator. It's testing your ability to use a graphing calculator to solve equations, okay? So what we're going to do is we're going to graph the exponential function 2 to the x, okay, and the linear function, they give 2x plus 11. All right, we're going to graph those two. All right, so you have a snapshot of the function window there, and then just hit graph, and then we have our exponential function, and then our linear function. The x value that satisfies the two equations resides at the intersection. Now, how do we find the intersection? Simply press second function trace for calculate, scroll down to intersect, press enter. It'll ask you for the first curve, look at it, y1 is the first one. The exponential curve, press enter. The second one is a linear function, press enter. Guess, scroll to somewhere in the neighborhood of the intersection point that you're looking for, because sometimes you have multiple intersections. Press enter again. And then what we're looking at is the x coordinate. So the intersection is 2.5572. So intersection is 2.5572. That's the x coordinate, and the y coordinate is 5.8856. 5.8856. 5.8856. Now we're looking for, you gotta be careful here, the x value that satisfies this equation. So this is your x coordinate, this is your y coordinate. We're asked to round it to the nearest tenth, okay? So you have to be careful with your rounding here. So we are extracting this. So we have 2.5572 rounding it to the nearest tenth or the first decimal place. You look at the number behind it. Is it 5 or greater? You carry 1. If not, then you truncate. Okay? Since it's 5 or greater, of course, we are going to carry 1 plus 1. So it's going to be 2.6 to the nearest tenth. Our answer is option number 2. Okay, if we round it incorrectly, we'll fall into a trap, 2.5, which is incorrect. So please make sure that you pay close attention to the place values when you are rounding. All right, let's take a look at question number 4. It says the lifespan of a 60-watt light bulb produced by a company is normally distributed with a mean of 1,450 hours and a standard deviation of 8.5 hours. If a 60-watt light bulb produced by this company is selected at random, what is the probability that its lifespan will be between 1,440 and 1,465 hours? So just a quick tip on when to use the normal CDF, the normal cumulative density function of the calculator. Has to do with the following condition, okay? Whenever you're given a boundary, how do you know that you're given a boundary? Look for the word between, and then you're given a lower and an upper bound, okay? Whenever you're given a boundary, two numbers that you're between, you're given the mean and the standard deviation, and you're asked to calculate the probability given the fact that the data is normally distributed. When you have these components all together, you're to use the normal cumulative density function feature of your calculator to calculate the probability. All right? Okay, well, actually, sorry, I meant to say normal cumulative distribution function. All right, so this is in our calculator, a nice little feature there. So to access it, you simply press second function variable to access the distribution functions in your calculator. So we have the normal probability density function and the normal cumulative distribution function. So you use this one right here, the cumulative distribution function. All right, so you press enter, and then let's talk about the syntax real quick. How do you enter the values into your normal cumulative distribution function? So this is how it goes. So normal cumulative distribution function, you have that, parentheses, you then enter the lower bound. That's the first entry, comma, so this is the syntax. This is how you communicate the information that you have with the calculator. All right, you have the lower bound first, and then the upper bound. And then you enter the mean value. And lastly, the standard deviation. That will be your last entry. Okay, so let me show you exactly what the values that I'm going to be entering in the calculator are. So we're going to do normal cumulative distribution function. The lower bound is the smaller of the two. So 1440, comma upper bound 1465. The mean is 1450, and your standard deviation is 8.5. Okay, so that's exactly how we'll enter it into our calculator. So we have 1440, comma 1465, comma 1450, comma 8.5, and I just close it and press enter. All right, so there you have it. Our answer is 0.84. Let's go back to the calculate, 8415 to 5 decimal places, 8415. Okay, so we can clearly see that our answer for question number 4 is option number 3. All right, let's take a look at question number 5, the last one in this part. It says, which factorization is incorrect? Okay, so be careful here. We're not looking for which one is correct, which is incorrect, which one is factored incorrectly. All right, this is an excellent problem to review your factoring skills. So let's start with the first option. We're going to factor all of them completely. So we have 4k squared minus 49. Okay, what do you notice about 4k squared and 49? They are all squares. What operation is this? This is minus or difference. So we're going to use the difference of squares formula. Okay, so the formula we're going to use for this is a squared minus b squared can be factored by rooting the first and the last term and expressing the roots as the sum and difference. Okay, so we're going to have the sum a plus b and the difference a minus b of the square root of the two terms. Alrighty? So in this case here, a square is 4k squared. So what do you get when you take the square root of that? That gives you a, right? So the square root of 4k squared, you square root 4, which is 2, and you square root k squared, which is k. That would be our a. Alright? To get b, we need to equate b squared to 49, take the square root. Square root of b is b, I'm sorry, square root of b squared is b, and then square root of 49 is 7. So what we're going to do is take the square root of the first and last, express it as a sum and difference. Okay, so we're going to have a plus b, 2k plus 7 times a minus b, 2k minus 7. Okay, just substituting these two values into the formula that we have here. Is that correct? Yes, it is. So option number 1 is correct. Remember, we're looking for what's incorrect. So don't stop here and start rejoicing that you found the correct answer. That's not what you were asked to do. Okay, a to the third minus 8b to the third. Now let's pause for a second. Look at a to the third, 8, and b to the third. What do you notice about these three values? They are all cubes. Okay, so there's a special formula for cubes. Now, this is something you want to remember. When you're dealing with squares, there's only the difference of squares formula. Okay? When you're dealing with cubes, it doesn't matter if it's a difference or sum of cubes. You can still factor it. So we're going to be taking a look at the, well, you know what? Let's just take a look at both of them. So the first one is a difference of cubes. A cubed minus b cubed. Now you have the factored state is a minus b times a squared plus ab plus b squared. And if you have a to the third plus b to the third, you have a plus b times a squared minus ab plus b squared. Now, have you heard about the SOAP formula? The SOAP acronym. Anyway, the SOAP acronym helps you to master the alternation of signs when you're applying the sum or difference formula for factoring sum of difference of cubes. Now, if you take a look at this sign right here, this is minus, right? The first sign is always the same. The second sign is always the opposite. And the last sign is always positive. So S means same, and O means opposite, and then this means always positive. These go together. Okay, so just keep that in mind. You look at a plus, 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 same. Next one is going to be the opposite of plus, which is minus, and the last is always positive. Okay, so SOAP should help you remember how to factor sum or difference of cubes. Now, all I need is A and B. And then I'll use the first formula to find the factored state of this term I have here. Okay, so let's see, we have a to the third. The first term is going to be a to the third. So to get a isolated, I take the cube root of both sides. All right, so we see that a is just a, And then to find b, we're going to set b to the third is 8b to the third. So what we'll do is we take the third root of both sides. Okay, so b is going to be, what is the third root of 8? What do you multiply by itself? 3 times to get 8. It's 2, right? And then square cube root of b to the third is b. Okay, so we have our a and b. So let's write down the formula again. So if you have a to the third minus b, oh, let me change the color here. Put the formula on top. So a to the third minus b to the third is equal to, remember, so a, first sign is the same, a minus b, and then a squared, the next one is going to be opposite, plus ab, and the last one is always positive, b squared, like that, all right? So in this problem, we have a to the third minus 8b to the third. Our a and b values are going to be a for a and 2b for b. All right? Okay, let's put it in. So if we put it in, we're going to have a minus b is going to be a minus 2b times a squared is going to be a squared plus ab is just a product of these two, 2ab plus b squared, you square 2 and 4, so it's 2b squared, okay? Let me just do this additional step so you see exactly what's going on. So we have a minus 2b plus a squared plus 2ab plus 4b squared. Okay, so is that what we have for option 2? Yes, it is correct. So the factorization for option 2 is correct. Now let's move on to the next one, option 3. All right, I'm going to put a copy of the problem down here so I don't keep scrolling up and down. Okay, let's factor that one. We have m to the third plus 3m squared minus 4m plus 12. Okay, we have 1, 2, 3, 4 terms. Anytime you have an even number of terms, you that's greater than 3, then you always want to factor by grouping. Okay, 4 terms, 6 terms, 8 terms, you want to try and factor by grouping. What on earth is that? Well, you divvy up your polynomial terms evenly. Okay, so here we have 4, so we split them down the center. From the first two, you extract the greatest common factor. In this case, the GCF is m squared, and you're left with m plus 3. Okay, and then here the GCF is 4, take out 4, and you're left with m. If you take out a minus 1 plus, guess what? The sign flips. This becomes minus 3, like that. Okay? All right, so how do we proceed? We want to look for common terms to factor out. Take a look at this. We have m plus 3 and m minus 3. Are they common? The answer is no. So guess what? We are done. That's the factored state of the polynomial. Okay? Okay, so what do we have? This one, m to the third plus 3m squared minus 4m plus 12. How's the factored state? M squared times m plus 3 minus 4 times m plus 3. And that's about it. Okay? Does it matter what we have there? Absolutely not. So this is the correct answer. That's the one that's incorrect. Okay? All right. Let's look at the last one. It's not the easiest to factor, but it's good for us to really sharpen our factorization skills so we can do well in the upcoming Regents exam. So let's take a look at this. Okay, now, how many terms do we have here? 1, 2, 3, 4, 5, 6. Remember, it was indicated earlier that if you have an even number of terms greater than 3, then you should use what? Factoring by grouping. How many pairs can we form here? You can form 2 pairs, okay? So you split it down the center. So you have the first pair and the second pair. Now, if you take a look at the first three terms, you ask yourself, how can I factor this? Is there a GCF here? And the answer is yes. You can pull out a t, okay? T is common, so you factor out a t, you have t squared plus 5t plus 6. And then here, what can you factor out? There's nothing, so you just pull out 1. You can always factor out a 1. You have t squared plus 5t plus 6. Now, inspect these two quantities in parentheses. What do you notice? You'll notice that they are identical. Okay, so factorization is all about pulling out common factors. So we're going to be extracting these two common factors on both sides of our partition, and that will give us t squared plus 5t plus 6. And then the terms that we factored out, t plus 1, are grouped together in their own nice little parentheses. That's what factoring by grouping is all about, okay? So we factored by grouping, but we have a quadratic trinomial here that might be factorable. So we're just going to make use of our x game, the shortcut. Since a is 1, we can factor this at the speed of light. So we have ac is 6, b is 5. What two numbers multiply to give you 6 and add to give you 5? 2 times 3 is 6, 2 plus 3 is 5. So this can be factored further into t plus 2 times t plus 3 times t plus 1. Okay, so that's the factored state of this polynomial. So let's write it down. T squared plus, t to the third plus 5t squared plus 6t plus t squared plus 5t plus 6 is equal to, if we want to put it in order, t plus 1 times t plus 2 times t plus 3. Okay, so if we scroll up, t plus 1 times t plus 2 times t plus 3, that is correct. So we see that 1, 2, and 4 are correct, and 3 is not. Thank you so much for taking the time to watch this presentation. We really appreciate it. If you found the contents of this tutorial helpful in your preparation for the upcoming Algebra 2 Regents exam, the Common Core version, please give us a thumbs up. Your positive feedback is extremely valuable to us. If you have any questions or comments concerning what we covered in this clip, or any questions about on the Regents exam in general, the math parts, just ask your question below, and we'll be glad to support you. Do not forget to subscribe to our channel so you can get updates to the remainder of this review series. More clips can be found on mathgotserved.com on the Regents prep. Thanks again for watching and have a wonderful day. Goodbye.